Hello friends, so this is the second lecture of Analytical Chemistry, second year BSc. Okay, now the next point is methods of expressing the precision. Last time we have seen the definitions of accuracy, precision, and methods of expressing the accuracy. Now today we have to see the methods of expressing the precision. So the first method is deviation. There are four methods: deviation, average deviation or mean deviation, third one is standard deviation, and fourth one is relative mean deviation or relative average deviation. Okay, so these are the four methods of expressing precision. We will see one by one in detail. So the first is deviation. Deviation is denoted by del. Deviation is denoted by del, or you can say delta. It can be defined as deviation is nothing but the numerical difference. This is a difference, numerical difference between the individual value or individual result and the average result. Numerical difference between the individual result and the average result of the data or of the measurements is called as deviation. It is denoted by the letter delta, symbol delta, or you can say del. So del is equal to in mod x minus x bar, in mod x minus x bar. So what is x? X is equal to individual result and x bar is equal to average result. Individual result means our individual observation measured value, we can say, and x bar is the average value or average result of the given data. So this is a simple definition of deviation. And the next one is second one is average deviation, or it is also called as mean deviation. We know that average and mean, these are the similar words. Average deviation or mean deviation, it is denoted by symbol delta bar or del bar. Okay, then delta bar is equal to the equation for this delta bar is equal to del 1 plus del 2 plus del 3 plus whatever the number of deviations are there, del n is the notation, divided by n. So n is again the number of observations or number of measurements. So del bar is equal to del 1 plus del 2 plus del n divided by n. So from this equation we can easily say the definition of average deviation or mean deviation. Okay, so the mean of deviations or the average of deviations of the given data, of the given set of data, is called as average deviation or mean deviation delta bar. What is the definition? The average of deviations or the mean of deviations for a given set of data is called as average deviation or mean deviation. It is simply, we have calculated here, the equation or the formula is very simple. It is nothing but the summation of all deviations divided by the number of observations or number of measurements. Okay, so this is the simple definition and simple equation. Then the next, third one is standard deviation. It is denoted by small s, standard deviation. So standard deviation, the formula is s, small s is equal to square root of del 1 square plus del 2 square plus del 3 square plus del n square divided by n minus 1. So all these figures are under root or under the square root. Okay, so from this again we can easily say the meaning or the definition of standard deviation s. So what is standard deviation? Standard deviation can be defined as the square root of sum of the squares of deviations divided by 1 less than the number of measurements. 1 less than the number of measurements is nothing but standard deviation or simply s. See again, standard deviation small s is equal to under root of or square root of del 1 square plus del 2 square plus del 3 square plus del n square divided by n minus 1. Okay, so according to this equation we can define this standard deviation s is equal to square root of sum of squares of deviations divided by 1 less than the number of measurements. So this is the very simple definition of standard deviation. Okay, as compared to standard deviation, the average deviation and simple deviation has less significance, while the standard deviation and the relative standard deviation or relative mean deviation has more significance in the calculating the precision and calculating the precision or expressing the precision. Okay, then the final one, that is the fourth one, is relative mean deviation or relative standard deviation. It is also called as relative standard deviation. I have written in abbreviated form. So relative mean deviation has no particular symbol at all. Relative mean deviation, it has no particular symbol. So that's why I have written in abbreviated form RMD or RSD is equal to mean deviation. Mean deviation is nothing but average deviation. Mean deviation is nothing but average deviation divided by mean value of the result or average value of the result into 100 or 1000, because it is again expressed in terms of percentage or in parts per thousand. If we have to express in percentage, then multiply this figure by 100, or if we have to express it in terms of parts per thousand, that is PPT. So instead of 100, divide this ratio by figure of 1000. Okay, so this is the relative mean deviation or relative standard deviation. RMD or RSD is equal to mean value or average value of the result divided by mean deviation divided by mean value of the result, or average deviation divided by average value of the result into 100 or 1000. Okay, so these are the main four methods for expressing the precision. Okay, then on the basis of that, we have some numerical problems. Let us say this is the first example or first problem. So this is the data given in the numerical problem. So percentage of iron in the sample are in this way. So there are 4 samples, or we can say that sample is only one, but the different peoples have taken different observations and they found that the different 4 observations. Okay, so the first one is 52.25 percentage, 52.60, 52.38, 52.47. Okay, so these are the 4 observations or measurements taken by the 4 peoples or 4 students, let us say. Okay, so this is the percentage of iron in the sample, and for this data we have to calculate the deviation, then mean deviation, then standard deviation and relative mean deviation or relative standard deviation that we have to calculate for this data. Okay, so it's a very simple. First of all, what we have to do, what is the first deviation? We have to calculate the deviation. Deviation is equal to delta is equal to in mod x minus x bar. This is the formula. So what is the meaning of mod? Mod means it has no sign. Whether our answer is positive or negative, it has no any significance. We should take the answer in positive figures. This is the meaning of mod. So we need to calculate the deviation, we need here x bar. So what is x bar? Average value of the given data we have to calculate first. So for that, these are these samples or these are the individual results. The total of the result is 209.70. So first of all, we have calculated the mean or simply average, mean or average of the given data. So I have calculated, I have do sum of all these 4 observations. It is 209.70 and number of observations are 4. So 209.70 divided by 4, it is equal to 52.42. You can calculate yourself by using calci or calculator at your home. Okay, very simple. So this is the mean value of the result. Then our first attempt or our first task is deviation, to calculate deviation. So what is deviation? This is the mean value and this is the individual value. So delta is equal to x minus x bar means 52.25 minus 52.42. What is the answer? It is minus 0.17. But all these figures are in mode, so that's why no need to take negative sign, only 0.17 is the answer. Again 52.60 minus 52.40, answer is 0.18. So in similar way, this figure minus this figure, you get this figure minus this figure, you get this figure. Okay, so this is the deviation we have calculated for all these results. Then again, next one is mean deviation or average result. Average deviation is we have to calculate. For again, we have done the summation of all these deviations, it is 0.44. Okay, and mean deviation, the value or the formula is very simple. Do sum of all the deviations divided by number of observations. So this is the sum of deviations. 0.44 divided by number of observations are 4. 0.44 divided by 4, it is equal to 0.11. Okay. Then del square. Del square is what? Standard deviation. Sorry. To calculate the standard deviation, standard deviation S, we have to first of all know the value of del square. So this is del. These are the del square values. 0.17 square, 0.0289, 0.18 square, 0.0324, 0.04, 0.0016, and 0.05, 0.0025. Very simple. Then these are the del square values. Okay. And what is the formula for S? S is equal to under root of square root of summation of squares of the deviations. Summation of squares of the deviations. Okay. So this is the sum. I am again here done here the summation addition of all the del square values. Okay, that is needed in this formula. So in this formula, so standard deviation S is equal to under root of square root of this figure divided by n minus 1. So n is number of observations are 4. So n minus 1 is equal to 4 minus 1. So under root of 0.0654 divided by 4 minus 1. You can use your term calci. So the answer is 0.14. Answer is 0.14. So in this way, in this tabular form, we have calculated the del study, that is deviation, then mean deviation del bar, then standard deviation S. The fourth one is remaining, and that is relative mean deviation or relative mean deviation or relative standard deviation. The formula is this: mean deviation divided by mean value of the result. Mean deviation is what? 0.11. So 0.11 divided by mean value of the result is 52.42. So very simple, 0.11 divided by 52.42 into 100. So my answer is 0.2098%. Why percent? Because I have multiplied this figure by a number of 100. Then or we can express in PPT, that is parts per thousand. So again, this figure, this ratio into 1000 is equal to 2.098 ppt. Okay, so this is a very simple concept of methods of expressing the precision. There are 4 methods. Okay, deviation, mean deviation, standard deviation, and relative mean deviation or relative standard deviation. I hope you get all these points and solve this problem in your notebook also by using calculator. Okay, so thank you very much. Next lecture we will see the more problems based on this accuracy and precision. Okay, thank you very much.